Hi there, this is Robin Andrews from Academy here, and this is a video about an excellent tool for looking at Python code and tracing what's going on inside a Python program. Okay, so this is a URL up here. I'll share that in the video description, and there's loads and loads of examples built in. So if you want, you can either put your own code here, paste it, or type it, and then you can visualize the execution, or you can just use some of the excellent examples here. Okay, so this is a sample program called Hello, that's what they've called it. And it's got just some variable definitions, basically, variable assignments. And it's got a couple of functions, foo and bar. That's common names, like dummy names for functions. So let's see what happens when we execute this. So you see you have the program on the left here, and then you can step forward, okay? So if you've learned about debugging, this is often a function of a debugger, is the ability to step into code and into functions, out of functions, over functions. But this is a kind of simplified version, so you can just step one line at a time. And it's really useful because it shows in yellow the line that's about to be executed. Okay, so that's the code there on the left. And then on the right, you get a visual representation of what's going on in your program. Okay, so it's pretty awesome in terms of really understanding from a kind of visual perspective or a more kind of intuitive perspective what's going on inside a program. So the global frame, that means the variables that are available within the whole program. Okay, so we've got a variable called x, which is pointing here to a list, and the list has the values 1, 2, 3 in it. And we've got a variable called y, which is pointing to another list that has 1, 2, 3 in it. And then z, which is pointing to another list, okay, 4, 5, 6. And that's the reason we're seeing that, because I did a few steps already. Let's go back to the beginning, so we can see them being created. Okay, so that was x being created, and then y, and then z. And there's stuff here about references that you might find interesting, but that's not the focus of this video. Okay, you'll see that certain things are pointing to, it looks like they're pointing to something new, but they're actually pointing to the same thing. So here, y and z are pointing to the same list. And this visualizer makes that relationship really clear. Okay, and then we can go forward. Okay, we've changed the reference there, so now x and y are pointing to the same list. Okay, and now we put it back. Now, all of this might have been completely behind the scenes. You might not have known it was going on unless you had this kind of visual representation, or you understood how this stuff works with references in Python. Moving on. So, I mean, what I really recommend is you've kind of got this left brain, right brain thing going on in all sorts of learning situations. So you've got your right brain is about the intuition and the flow of it. And then you've got your left brain, which is like your analytical, you're kind of taking it apart and understanding how each part of the big picture works. Okay, and it's really good if you can get both of those kind of working together. So something like a visualizing tool is excellent for helping you to understand the big picture, but also here it can help you to understand the nuts and bolts. So you can kind of move between the two in terms of your focus. So you can think, okay, what's the flow of it? I can just click it a few times. Yeah, it looks like that's happening. Just get a feel for the flow. But then if there's some part of that flow that you really want to understand, you can then zero in on that and just say, well, what's going on? Let's go back a step, go forward a step. Yeah. And basically just trace through the algorithm until it really makes sense to you. And some algorithms are quite complex, and you have to do a lot of this. And it's almost like fishing or something, like fishing for understanding. So, you know, you can't force the understanding to come, but you can patiently trace through the program a few times. Maybe make a note to yourself to focus on different parts as you go through, pose certain questions and then answer them as you go through, almost like the scientific method. And a tool like this is really going to help you with that sort of stuff. So that's really what I'm doing here. I'm not going into the details of it. I mean, we've got these function definitions. What can I say about those? Yeah, here you see foo and bar. These have now been defined as functions in the global frame. So foo is a function and bar is a function that's been defined. So they're still like global variables. But then we can kind of trace through what happens as they get called. Okay, so that's basically all there is to it. Another great thing about this is you can actually share whatever code you're working on. You can generate a URL and you can send it to your students or your friends. And then you can all be like on the same page, literally. Now, let me just show you a couple of other examples, because there are some really interesting ones here. So if you go to the example section here, depending on your level, you know, you can pick something. Insertion sort, for example, is great for GCSE computer science, for some boards, not others. But it's definitely worth tracing through that one to really get an understanding of what's going on there. List comprehensions, that's more Python than like computer science in general. Some languages don't have them, but if you want to understand how they work, that's great. And then you've got some more kind of maths related stuff. So if you want to understand the factorial function, and this is great if you want to understand recursion, actually, because it's quite a difficult topic and seeing it kind of visually explained. So let's just go into that. This is more A level. If you're on some kind of curriculum, okay, you wouldn't be doing this at GCSE, but it's certainly an important part of computer science. So you can look at the fact that we've got factorial defined, and then within that function, we're calling the same function that we're in with a reduced value. Okay, so this is the classic introduction to recursion. And you can get some idea of how it works just by tracing through it. Okay, so trying to find factorial of 6 involves finding factorial of 5, which involves finding factorial of 4, etc., etc. So moving forward until you finally hit what's called the base case. So that's when n is 1. Okay, and then you start to return. Okay, so you're returning 1 from that, and then you're returning 2, and then you're returning 6. Okay, these are the factorial values until you get to the one that you originally asked for. Okay, so again, this video isn't about recursion or factorials, but I'm just giving you a kind of overview of some of the tools that are available for learning more about algorithms and programming in general. Okay, so I hope that was helpful. Like I say, I'll put the link to this tool in the video description. Let me know what you think in the comments. Don't forget to subscribe, and I'll see you in the next video.